Okay, so we are on to Module 1, Lesson 13, which is titled From Ratio Tables to Equations Using the Value of a Ratio. And today our goal is to be able to write an equation from a ratio table. So watch the video carefully, and of course, when you're in class, be sure to ask questions. All right, so it starts off with exercise 1 saying Jorge is mixing a special shade of orange paint. He mixed 1 gallon of red paint with 3 gallons of yellow paint. Based on this ratio, which of the following statements are true? So the first one starts off with 3/4 of a 4-gallon mix would be yellow paint. Well, if you look at this, let's go right here. Here's the mixture that they're talking about right there. Well, the total, if I were to make 4 gallons of paint, I would have 1 gallon of red, but I would have 3 gallons of yellow, which is exactly what it's asking us about. It's asking us about the yellow paint. So 3/4 of a gallon would be yellow paint. Well, I'm making 4 gallons, 3 of which would be yellow, and of course 1 would be red. So this in fact would be true. The second one says every 1 gallon of yellow paint requires 1/3 gallon of red paint. So if I'm going to make 1 gallon of yellow paint, okay, so now look at what we're saying is we're saying we have 1 gallon of yellow. Well, I still need to keep that 1:3 ratio. Look at our ratio. Our ratio is 1:3. Well, that means that if I'm only going to use 1 gallon of yellow, look what I did. I divided the yellow by 3. Well, that means I need to divide the red by 3. Well, as you know, as we've discussed in class, a fraction means division. That is 1 divided by 3. So it would be 1/3. So that is true. Every 1 gallon of red paint requires 3 gallons of yellow paint. Well, that's exactly what our initial statement reads. So that has to be true. 1 gallon of red paint. There's 1 gallon of red paint. 3 gallons of yellow paint. 3 gallons of yellow paint. That also has to be true. Let me get rid of some of this right. Oops, I didn't mean to get rid of that. Clear the board just a little bit so we can have some more room for future problems. There we go. This one we said was true. This one we said was true. Then it says there is 1 gallon of red paint in a 4-gallon mix of orange paint. Well, if you take the 1 gallon here, okay, so there's 1 plus the 3 gallons is a total of 4 gallons. So it would in fact have 1 gallon of red paint. That's also true. There are 2 gallons of yellow paint in an 8-gallon mix of orange paint. Well, we know that if I were creating a ratio table here, and let's do it right here. Let's see here. There we go. Here's what I'm going to do. I'm going to use, there we go. Perfect. 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 Slide that down so y'all can see it. All right. So my original ratio, well, if I had 1 gallon of red, 3 gallons of yellow, the total was 4. So I'll even label this for you. Red, yellow, and total. Now it's saying if there are 2 gallons of yellow paint in an 8-gallon mix of orange paint. Well, if I made this 8, okay, that means I'm making double the amount, which means I have to multiply this by 2 and this by 2. Well, clearly there's not going to be 2 gallons of yellow paint. There would be 2 gallons of red paint, not yellow. So that one is false. And again, by making the ratio table, it was much easier to see that clearly. All right. Based on the information on red and yellow paint given in exercise 1, complete the table below. All right. So initially it said that, remember, it was a 1-to-3 ratio. That means I have 1 gallon of red paint and 3 gallons of yellow paint. And if I have 2 gallons of red paint, well, 1 times 2 is 2. So I do 3 times 2, you get 6. And then over here, if I look here, it's saying, all right, now you have 9 gallons of yellow paint. Well, that means I took the 3 and multiplied it by 3. 1 times 3, of course, is 3. And then if I look at this next one here, okay, they're giving me the 12. Well, 3 times 4 is 12. So 1 times 4 is 4. And then here, now they're giving me the 5. 1 times 5 is 5, and 3 times 5 is 15. So that's what your ratio table would look like. And again, we're kind of following that same pattern that we had talked about back in lesson 9, where we have 1, 2, 3, 4, 5 going down in the red, adding 1 as we each go. And here we're skip counting by 3 in the yellow paint. Or you can see how we're doing it by multiplication, which is the way I talked you through it. So that's what your ratio table would look like. All right, now they kind of throw a little bit something at you. And this is where we have to kind of slow down and you need to really pay attention. It says Jorge now plans to mix red paint and blue paint to create purple paint. The color of purple he has decided to make combines red paint and blue paint in a ratio of 4-to-1. I'm going to just highlight that. There's an awful lot of writing here. Make sure we see that. It says if Jorge can only purchase paint in 1 gallon containers, construct a ratio table for all possible combinations of red and blue paint that will give Jorge no more than 25 gallons of purple paint. All right. So let's do that first. Well, let's finish reading the question. Then it says write an equation that will let Jorge calculate the amount of red paint he will need for any given amount of blue paint. Then you're going to write an equation that will allow Jorge to calculate the amount of blue paint he will need for any given amount of red paint. If Jorge has 24 gallons of red paint, how much blue paint will he have to use to create the desired color purple? And finally, we're going to end with if Jorge has 24 gallons of blue paint, how much red paint will he have to use to create the desired color of purple? All right, let's start with, let's just fill in our table to begin with, okay? So our original ratio here is red paint 4, blue paint 1. Now notice what they did to you here. I say did to you, I mean, that sounds awful, but it's not like they're trying to hurt you. They're trying to get you to think. Notice they list the red paint before the blue paint. So the red is my 4, excuse me, and the blue is my 1. But then when you go down to the table, look what they did. The blue is first. The red is second. Okay, and then as I continue down my table, okay, I've got 2. Notice this makes 5 gallons. I'm just going to write over here 5. Just so that I have the total, because remember it says no more than 25 gallons. Well, if I have 2 here, I have 8 here. That's 10. 3 here, 12 here, that's 15. 4 here, 16 here, that's 20. And then 5, notice I'm counting by 1s going down here because my initial number of gallons of blue paint was 1, and I'm skip counting by 4s or multiplying the 4 by consecutive numbers to figure out the red as I go down. 20 and 25. So that gives you the amount for 25 gallons of purple paint. So when they talk about relationship here for the third column of exercise 3, what they're saying is basically what is the relationship between the two? In other words, how would you figure out how many gallons of red paint you would need if you know the gallons of blue? Well, here the red paint is 4. Well, to get 4, you would do 1 times 4. In other words, you would do 1 here times the 4. So to have 8 gallon, if you have 8 gallons, in order to figure out how many gallons of red you would need, and you know that you have 2 gallons, you would do 2 times 4. So in other words, in order to figure out how many gallons of red you need, what would you do with the amount of blue? I said yellow, but I meant blue. So here they're saying, okay, the second column, the amount of column in column red is 12. Well, in order to figure out that I need 12 gallons of paint, I would take 3 gallons of blue paint and multiply it by 4. To get 16 gallons of red paint, I would do 4 times 4. And then to get 20 gallons of red paint, I would do 5 gallons of blue times 4. So in other words, what you're doing is they're trying to get you to see that in order to figure out how much red paint you need, take the amount of blue and multiply it by 4. That's all they're saying there is, okay, how are we going to figure that out? So now how can we write that as an equation? Well, let's work to that, okay? Let's do this right here. Oh, we didn't finish this, did we? We still have to do the rest of this. So it says, write an equation that will let Jorge calculate the amount of red paint he needs, or he will need, if given the amount of blue paint. So in other words, what they're saying is, if you know this, how are you going to figure out this? If you know how much blue, how are you going to figure out the red? Well, let's do this. Notice here, I've got an awful lot of writing. Let me get rid of some of this writing and so I can make it clearer for you. Notice what they've done here. They've given you the fact that they want you to call blue B, and they want you to call red R. So, to calculate the amount of red paint, in other words, what are you going to do? There we go. In order to calculate the red, what would you do to the amount of blue? Well, you can see that no matter what I do here, no matter what my value is for the blue, if I multiply it by 4, I'm going to get the amount of red. So to get the amount of red paint, you take the amount of blue and you multiply it by 4. Now, we're going to change this slightly. This is accurate. This is correct. However, we're not going to use this multiplication symbol that you're used to using. We're going to change it. And what we're going to do is we're going to write this way. This is the proper way to write this equation. The amount of red paint is 4 times the amount of blue. Now you're like, wait, whoa, time out. There's nothing between the 4 and the B. So how do we know what we're doing? Well, in math, if you have a number and a letter right next to each other, by the way, the number always comes first, then you are to multiply. In other words, if there's no operation given, multiplication is assumed. So that means that here what they're saying is that to figure out the amount of red paint, you're going to do 4 times the amount of blue. Now the 4, okay, this number right here is called the coefficient. Whoa, you don't need to know that yet. We're actually going to learn that in module number 4 when we do the very, very beginning of algebra. However, this is the proper way to write this equation. So R equals 4B, 4 being the number that we're multiplying by the gallons of blue paint. So whatever the gallons of blue paint are, we're going to multiply it by 4. And that's what we did in this relationship. That's all we're doing here. So if you look at this, it says R equals 4B. Well, that means that what I did was I took the amount of blue paint in this first one here. Notice it was 1. And I multiplied it by 4. There's the amount of red. Okay. I took the amount of blue paint, multiplied it by 4. There's the amount of red. So that's what we did. Then it says, write an equation that will let Jorge calculate the amount of blue paint he will need for any given amount of red paint. This is a little trickier. This is just a little bit trickier. I'm going to show you 2 ways to write that. If I can get my, unfortunately, I'm still working with a very old smartboard, so it doesn't always want to do what I want it to do. Here we go. All right, let me erase some of these other markings. Let me get rid of this. Get rid of all this. Oops. All right. So look what they're asking for now. Now what they're saying is, how would you figure out the amount of blue paint if you know how much red? Well, there's 2 ways to do this. Notice the relationship here. Gosh, I've kind of really messed up this table for you here, didn't I? I'm going to get rid of this. I don't even need this anymore. Okay, let's go back to this. All right. So what they're saying is, what if you know that you have 4 gallons of red paint and you need to figure out how many gallons of blue? Well, here, what you're going to do is you actually, if you think about it, you're going to take the red, and if I divide by 4, I'll get this. Same thing here, the relationship here. I could divide by 4. So what they're saying is, you know you have 12 gallons. How much blue paint do you need? Well, just divide the 12 by 4. You know you have 16 gallons. How are you going to figure out how much blue? Divide by 4. You have 20 gallons of red. How are you going to figure out how much blue? You're going to, divide by 4. So you're always dividing by 4. So really you can do R divided by 4. I will, by the way, this means division. Okay. And you know what? Right now, because we're still kind of learning this, I would even accept this. R divided by 4. I prefer this, but I will accept that. Now, what would I really like to see? I'd like to see multiplication. Sorry, you're dividing. Actually, I can multiply. Okay. And I can do it this way. I could write it as blue equals. Now, look at what my ratio is. 1 to 4. Okay. In other words, I'm trying to figure out how much blue and I know how much red. Well, the value of that ratio is 1/4. Remember, the value of a ratio is the ratio written as a fraction in lowest terms. So I actually also could write it as blue equals 1/4 R. Whoa, how's that work, man? Well, we know that we can also do this. Blue equals 1/4. Now, I am throwing so much at you in this lesson. All right, that's okay. You guys can handle it. I know you can. I have faith in you. Okay, this dot also means multiply. So when you use the X, okay, that means multiply. So does that dot. So now this means I'm going to do 1/4 times R. Same thing that I wrote above, except I put in a multiplication dot. I don't typically want you to use it if we don't have to, but in this case, I'm going to, because I can do this. Now I'm going to make R a fraction. Well, how are you going to make R a fraction? It's a whole number. You can take any number, any whole number, and make it a fraction by putting it over 1. Whoa. So now look what you're left with. 1 times R, R. 4 times 1, 4. And then we're right back to where we started. Just like that. Ah, wow, there's a lot I just threw at you. So I would accept any one of these answers. Okay, and here's how I'm going to list them. And I'll accept any of them. So please don't think that because I'm writing good, better, and best, but that's all I'll take. That's good. This is better. That's the best. However, I will accept any one of those. Well, I just threw a lot at you. So let's see if we can apply it a little. Oh, let's make sure I didn't finish this, did I? You guys have got to call me on that. So if Jorge has 24 gallons of red paint, how much blue paint will he have to use? All right. So we know this is what we're doing now. Okay. We're looking at this and we're saying, okay, we know how many gallons of red paint he has. We need to figure out how many gallons of blue paint. Okay. So by the way, this was B equals 1/4 R, or B equals R divided by 4, or B equals R divided by 4. Good, better, or best, better, good. That's how I wrote it. So how can we do this? We're going to take the 24 gallons. We know how much red paint we have. So that means we're going to use this equation this time. Because we know how much red paint we have, we need to figure out how much blue. So remember, R equals 4B, and B equals 1/4 R. And this is also B equals R divided by 4. B equals R divided by 4. I'm going to write them all. So we know how much red paint we have. We have 24 gallons times 24. We have 24 gallons of red paint. Okay. So that means I'm going to do B equals 1/4 times 24 over 1, which is going to be equal to 24 divided by 4, which means that I need 6 gallons of blue paint. 24 divided by 4 is 6. Now, if you said, wait a minute, I'm just going to use this because I understand that, fine. 24 gallons of red, you're going to divide it by 4 to figure out how much blue. You need 6 gallons of blue paint. I'm good with that. I know I gave you all this. This is what Engage New York wants you to know, wants you to see. And that is what I'm going to want you to do when we get into algebra, because it's not going to be as straightforward later on. However, for now, if you do it this way, life is good. Then it says, if Jorge has 24 gallons of blue paint, how much red will he have? Well, look, what we're saying is how much red. So when it's all by itself and the equal sign, we're trying to figure out this question, how much of this we know this. So that means the amount of red paint is going to equal 4 times the amount of blue paint. In this case, they told us what it is. Wasn't that nice of them? They said, you have 96 gallons of blue paint, man. All right. Well, 4 times 24 is 96. So I would need 96 gallons of red paint. I know that's a lot. So let's try this. Now, it says using the same relationship of red to blue from above, create a table that models the relationship of the 3 colors, blue, red, and purple. Okay, so now what they've done is they put in total paint, T. This is also the purple. Okay. So remember, our relationship is if I have 1 gallon of blue, 4 gallons of red. Now, if I have just 1 gallon of blue and 4 gallons of red, I would have 5 gallons total. if I have 2 gallons of blue, 8 gallons of red, I have 10 total. 3 gallons of blue, and now I've got 12 gallons of red, I have 15 gallons total. If I have 4 gallons of blue, and now I have 16 gallons of red, that means I've got 20 gallons total. And if I have 5 gallons of blue, that means I have 20 gallons of red. I have a total of 25 gallons of paint. Now, look, again, looking at the structure of the table. The blues I'm counting by 1s, the reds I'm counting by 4s, the total I'm counting by 5s. All right, let's see what else it tells us to do here. Then it says, let B represent the number of gallons of blue, let R represent the number of gallons of red, and T represent the number of gallons of purple. Then write an equation that models the relationship between the blue paint and the total paint and answer the questions. So what they're saying then is, in order to figure out, let's do this. In order to figure out the amount of total paint you need, and you know how much blue paint, what they're saying is you know this amount, you know that much. Okay, so if you plug this in, and if you think about what we're doing here, okay, what they're saying is if you know this, how are you getting this? In other words, what do you do to 1 to get 5? What do you do to 2 to get 10? What do you do to 3 to get 15? What am I doing to 4 to get 20? What am I doing to 5 to get 25? Well, in order to find the total, I'm going to take the amount of blue paint that I have, and I'm going to multiply that by 5B. And I can check my work. Okay, so this is the amount of blue paint right here. And what I'm saying is take this amount, multiply it by 5, and you should get the total. Well, if I start here, 1 times 5 is 5. If I have 2 gallons of blue and I multiply it by 5, I get 10. So I can check my work with my ratio table. If I have 3 gallons of blue, I should have a total of 15. 4 gallons of blue, multiply that by 5, I get 20. 5 gallons of blue, multiply that by 5, and you get 25. And it says, what is the value of the ratio of total paint to blue paint? All right, well, the ratio, let's write the ratio first. The ratio of total paint to blue paint. My total paint is 5. That's this right here. 2. The blue paint is 1. There's the ratio. Remember, the value of the ratio is a ratio written as a fraction in simplest form, or lowest terms. 5 over 1, which of course we know just equals 5. So check this out. Here's the total. Whoops. I put my marker down and I was trying to write with my finger. There's the total. There's the blue. There's the total. There's the blue. So I wrote it as a fraction. And then I put it in lowest terms in its simplest form, which 5 over 1 is just 5. Look where we used the 5. There's the value of the ratio right there. So there's the 5, there's the value of the ratio. So I've answered this last part right there. I've answered that by saying the value of the ratio is used as a coefficient, the number of multiplying the number of gallons of blue paint by. I know there's a lot here. It can be confusing. I get that. Just stay with me, guys. All right. I don't want to make this video too long, but I want to keep going. During a particular U.S. Air Force training exercise, the ratio of the number, I'm going to highlight this. The ratio of the number of men to the number of women is 6 to 1. It says use the ratio table provided to create at least two equations. Huh. That model the relationship between the number of men and the number of women participating in this. All right, let's try this. First, let's do the actual ratio table. Now look, you got to read these carefully because I don't think they're trying to trick you, but they haven't made it easy, because look what they did in their ratio table. The left column is women, the right column is men. But in my ratio, they put men first, women second. So notice my left number, the first number is 6, which is men, and the second number, 1, represents the number of women. So here, I've got to make sure that I go, for every 1 woman, there are 6 men, which means if I have 2 women, we have 12 men. If I have 3 women, I have 18 men. If I have 4 women, okay, I've got 24 men. And if I have 5 women, I have 30 men. And as you can see, if you know your multiplication tables, this is much easier. So be careful, read these carefully. Don't go too fast. I have students that like to race through their homework because they've got some very important fortnight they need to get in. No, take your time. All right, so let's write 2 equations here. First of all, if I want to figure out how many men took part in the exercise, what would I do to the number of women? In other words, I know how many women I have, and I want to figure out how many men. So this is what I'm trying to figure out. And now what would I do to the number of women to figure that out? Well, let's see. Here I've got 1 to 6. So I could either add 5 or multiply by 6. But check this out. Now, I'm going to tell you right now, the relationship between the columns in a ratio table, it's always going to be multiplication. It's never going to be addition. So here, I did 1 times 6 is 6. 2 times 6 is 12. Seems to be a pattern here. Let's check it. Well, 3 times 6 is 18. 4 times 6 is 24. And 5 times 6 is 30. So that means I'm going to take the number of women and I'm going to multiply it by 6 to figure out how many men. But remember, we really do it this way. We always write what we're multiplying by first. The number always comes first. It's called the coefficient, and it always comes first. And I want you to get used to that. I know that we're really going to learn that more when we get into algebra in module 4, as I told you, but I want to get used to it now. So now we're going to say, okay, how are we going to figure out how many women if we know how many men? So remember, this is what we're trying to figure out, which means we know how many men there are. Well, look what we do. Now I'm going this way. So now I'm going instead the opposite of multiplication. So I'm dividing by 6. 18 divided by 6 is 3. 24 divided by 6 is 4. 30 divided by 6 is 5. So I'm going to take the number of men, I'm going to divide it by 6. Now, this is what I prefer. 1/6 M. So the number of men, okay, multiplied by 1/6. However, if you were to do women equals men divided by 6, I will accept it. If you were to write the number of women is the number of men divided by 6, I will accept that as well for now. So I will accept any one of these 3. Remember, best, good, sorry to write all over you, ma'am. Okay. So this would be, this is good, this is better, that's the best. Now let's take a look at the question. Okay, so we're going to use one of these equations to solve this question. If 200 women participated in the training exercise, use one of your calculations to calculate the number of men who participate. So we don't know how many men, but we do know how many women. So what you're asking yourself is, all right, so I need to figure out how many men. That's by itself an equal sign. That's what we're trying to solve. And that's going to be equal to something to the number of women. So we're either going to multiply the number of women by something or divide the number of women by something. So let's go up here. look, this is the equation. I'm going to do it in red just so that we can stay on the same page. This is the equation right here that helps us decide how many men. And what it tells us to do is to take the number of women and multiply it by 6. See, it says 200 women. It's almost like putting the 200 in my ratio table right here. And I've got all of these divisions. So let's do this. All right. So remember, we did, oh yeah, we multiplied that by 6. We multiplied that by 6. So whatever the number of women I have, I'm going to multiply by 6 to figure out how many men. So here I got to do the same thing. I got to do that multiplied by 6. So men equals 6 times the number of women. Now we know how many women there are. So we're going to do 6 times 200. Well, that means the number of men is going to be 6 times 200 is 1,200. So if 200 women participated in the training exercise, then 1,200 men participated in the training exercise. All right. I know there's a lot to this. All right, let's take a look at this one here. Malia is on a road trip. During the first 5 minutes of Malia's trip, she sees 18 cars and 6 trucks. Assuming this ratio of cars to trucks remains constant over the duration of the trip, complete the ratio table using this comparison. Let T represent the number of trucks she sees and C the number of cars. So let's do this. This is important. She sees 18 cars and 6 trucks. Wasn't that interesting? Well, I can't, on my ratio table here, they really haven't given me enough information to complete it, except that they do give me the 6 trucks. So I know that when she sees 18 cars, so I'm going to look in this one, because in the information in the table, it tells me that she saw 18 cars, which means the 6 goes right there. So by filling that in, I can start to see where my ratio table is going. Well, now, if I want to figure out this row, 6 divided by 1 is, 6 divided by 6 is 1. So 18 divided by 6 is 3. There's the ratio table that starts with the ratio in its simplest form. Then if I do 1 times 3 is 3. 3 times 3, well, this is going to be 9 then. But wait a minute, Mr. Bogren. We're not skip counting by 3s as we had previously. No, we're not. Because look at the information they're giving me in the table. Now, if there was a 2 in between the 1 and the 3, then I would have a 6 in between the 3 and the 9, and I would be skip counting. But the table now, they're not going consistent. They're not just skip counting. So what I do on a table like this is I start with what I know. I divide it by 6 to get here. So I'm going to divide by 6 to get to 3. Then 1 times 3 is 3. So 3 times 3 is 9. Now 1 times 12 is 12. 3 times 12. So this is going to be 36. And then look what they're doing here. They go to 60. Well, 3 times 20 is 60. So 1 times 20 is 20. So you got to be careful in ratio tables. They're not always going to be a consistent pattern going down the table if they throw a curveball at you like this. So now it says, what is the value of the ratio of the number of cars to the number of trucks? Well, the ratio of cars, the number of cars to the number of trucks is 3 to 1. So we're going to write that as a fraction, and then we're going to put it in its simplest form. So then it says, what equation would model the relationship between cars and trucks? Well, it's actually 2 equations I could write, believe it or not. Let's start this one. This says, what's the relationship between cars and trucks? Well, to figure out the number of cars, okay, and there's the value of the ratio, 3. So I'm going to take the number of trucks and I'm going to multiply that by 3. So the number of cars is going to be 3t, or 3 times the number of trucks. Now the inverse of that is going to be true for the number of trucks. So to figure out the number of trucks, you would do 1/3 the number of cars. Or if it's easier for you, trucks equals cars divided by 3, or trucks equals cars divided by 3. Any one of those. So I'm going to put 4, okay, any one of those. So at the end of the trip, Malia counted 1,254 trucks. How many cars did she see? So remember, she's asking about the number of cars. So what I'm going to do is I'm going to say, okay, this is what we're trying to figure out. I want the C all by itself because that's what we're trying to solve. Oh, well, that means I'm going to use this right here because there's the cars right there. What do I do to the number of trucks? I multiply it by 3, 3t, which means that what I'm going to do then is I'm going to do, this is called substitution, 3 times the number of trucks you saw, 1,254. So I'm going to do 3 times 1,254. And very, very neatly, I'm going to do 1,254 times 3. Well, 3 times 4, of course, is 12. 3 times 5 is 15, plus 1 is 16. 3 times 2 is 6, plus 1 is 7. And 3 times 1 is 3. So now I know that the number of cars is 3,762. All that's left, give myself a little bit of space here. If Malia counted 1,254 trucks, then notice it says how many did she see? Then she saw, not seesaw, she saw 3,762 cars. We're New Englanders, so we don't always pronounce the R's. Cars. All right. I hope that helps you. I really do. Let's do one more. I know this video is turning into long. You can skip over this. If you think you understand this, you're certainly more than welcome to skip over this. But if you'd like to watch one more example and you think it'll help you, then please do. So it says Kevin is training. Oops, sorry about that, guys. There we go. Kevin is training. There we go. To run a half marathon. His training program recommends that he run 5 minutes and walk for 1 minute. Let R represent the number of minutes running. Let W represent the number of minutes walking. So I've got R, let's see, 5 minutes. He runs for 5, walks for 1. Boom. All right, let's see here. Oh, look it. Here's another one of those tables that doesn't necessarily skip count, because look what we're doing. What do we do to 5 to get 20? Well, I would multiply by 4. So what am I going to do here? I'm going to multiply by 4. 1 times 4, of course, is 4. So if he runs for 20 minutes, he should spend 4 minutes walking. Then look what happens. Okay, so I'm going to get rid of this. Now, he says, all right, he spends 8 minutes walking. Well, that means I multiply this by 8. So I'm going to multiply that by 8. And there's 40. And I would do the same thing for the last column, except now, look what they're doing. Now they're giving me the 5. Ah. Well, here, I would multiply by 10. So I got to multiply that by 10, and I get 10. All right, so I've completed my table. Let's see what this says. What is the value of the ratio of the number of minutes walking? So it's asking me for the number of minutes walking to the number of minutes running. Interesting. I wonder why they're doing that. Well, walking is 1. Running is 5. So the value of the ratio is 1/5. What equation could you use to calculate the number of minutes spent walking if you know the number of minutes you spent running? All right, so this is what they're asking you to do here. The number of minutes, you need to calculate the number of minutes walking. So this is what I need to figure out. And I know how many minutes I spend running. Interesting. Well, let's see. Well, if I spend 5 minutes running, looks like I would divide by 5 there. Okay, remember, this is how much you know. This is what you're trying to figure out. Well, what if I spend 10 minutes running? Oh, look at that. Looks like I'm dividing by 5. What if I spend 20 minutes? Divide by 5. That might be the world's ugliest 5, right there. The world's. I just set the record for the world's. I should be in the Guinness Book of World Records. Ugliest 5. Whoops, don't know what happened there. Ugliest 5 ever written on a smart board. Okay, I don't know what's going on here. My board has gone crazy. There we go. All right, let's try this again. My board is not working. I love these old boards. Very old board, guys, and sometimes it works and sometimes it doesn't. And guess what? My board just froze on me. Oh, something's happening here. Let's see what's happening. All right, maybe we're getting somewhere. There we go. So I'm dividing by 5. Here, 40 divided by 5 is 8. And here, I'm dividing by 5. Oh, another one, ugly as 5. So it looks like I would take the number of minutes running and divide it by 5. Well, remember, here's the best way to write that. 1/5 R. And you're like, yeah, but I can't wrap my head around multiplying by the fraction. Can I just write division? Sure, I'll let you. The number of minutes running divided by 5. Oh, I hate fun with fractions. All right, for now, we really haven't gotten into algebra yet. I'll even let you do this. Show me that you understand it and I'm good. Okay, same thing goes. That's good. That's better. Jackpot. That's the best. All right. I hope this video has been helpful. Okay. There's the summary of what we just did. The value of a ratio can be determined using a ratio table. This value can be used to write an equation. Multiplication table can be a valuable resource to use in seeing ratios. Different rows can be used to find equivalent ratios. We've gone through all of this very carefully. I hope you know your multiplication tables. It makes life so much easier. All right, so for homework for my classes, and I know I have people that watch these that aren't necessarily in my class, but for the people that are in my class, you're going to be doing questions numbers 1 through 4. So I am going to ask you to recreate this ratio table on a separate piece of paper and then read the question carefully. So I would start by highlighting here a recipe calls for 1 cup of white sugar for 3 cups of brown sugar. So fill in your ratio table, write the value of the ratio of white sugar to the amount of brown sugar. Make sure you're putting that in the right order. So remember, it's white to brown, then write the value of that ratio, write an equation that shows the relationship of the amount of white sugar to the amount of brown sugar. In other words, what they're asking you to do here, and make sure that you're very careful in how you write this, check your work, go back to the ratio table and double check your work to make sure that you have it. But what they're really looking for here, and this says, it's kind of vague, but what I'd like to see you try to do is this. W equals something brown. Now, it might be multiplication, might be division. I'm not going to tell you. I'd like you to figure it out. Then, if you can, right, how would you figure out the brown if you knew how much white? Explain how the value of the ratio can be seen in the table, okay? The hint would be go back to the first row and explain how the value of the ratio can be seen in the equation. Where in the equation is the value of the ratio is what they're asking for there. So in other words, think about what the value of the ratio is, and then where in these equations do you find the value of the ratio? So that's going to be the homework for my classes. I hope this video has been helpful. If you have questions, as always, you're more than welcome to email me. Otherwise, have a great day.